Here we have a square metal plate attached at the center to an oscillator, a device that moves up and down, up and down. And this knob over here changes how many times the plate goes up and down every second, or the frequency of the motion. And as we change the frequency, the sand on the plate forms beautiful patterns. Why? This is like what happens when you drop a pebble in the water and you form circular ripples. Here, we're actually making ripples in the metal. But how can circular ripples make shapes like these? Well, the ripples are circular, but the plate is square. As the ripples get bigger, they reach the edges of the plate, bounce back, and crash into the new waves that are coming out from the center. What happens when waves crash? Depends on how they crash. If the crest of one wave crashes with the crest of another wave, the final wave will be as tall as the two of them combined. But if the crest of one wave crashes with the trough of another wave, they can cancel out. This way in which waves add is called interference. When two traveling waves collide and interfere, it is possible to end up with a wave that does not travel, a standing wave. A standing wave is like a guitar string. It just stands there, oscillating. There are points along a standing wave that move a lot, and points that don't move at all. So what happens if we pour sand on a standing wave? Where will the sand go? The sand can only stay on the points that don't move. And this is precisely what we see here. These shapes show the points where the plate does not move. These patterns only form at special frequencies. Why is that? As the plate is oscillating, there are many waves sloshing back and forth, back and forth. And if the frequency is just right, the waves will bounce off of the edges of the plate at exactly the right time, so that they will always cancel at exactly the same spot every time.